Hi friends, and welcome to today's class Ace Math with Joy. Today we're going to be looking at a very interesting math topic, indicial or exponential equations. So if you're going to be writing maths in WAEC, in NECO or JAM, this topic is for you. Alright, if you haven't seen my video on indices, the laws and applications, please, I would advise that you watch that before this because that knowledge is needed in indicial equations. So let's get started. Indicial or exponential equations can actually come in two forms. All right. Now, the first form, as you can see, is when the unknown is in the exponent. When the unknown is in the index or exponent. So what do we do? Now, we try to express the bases to be the same. All right. So in doing that, we will have that 2 raised to the power of x is equal to 2 raised to the power of 2. So when that happens, the bases can cancel out and then we pick the powers. So we have x to be equal to 2. Did you see that? Okay. So now what happens when the unknown or what you're looking for is the base and not the power? What do we do? So what we do is, you see, if you have x raised to the power of 2, the denominator of this 2 is 1, right? Now, what is the multiplicative inverse of 2 over 1? The multiplicative inverse of 2 over 1 is 1 over 2 because it is 1 over 2 that will multiply 2 over 1 to give us 1. All right? Good. So we have it to be equal to 4 raised to the power of 1 over 2. So if you multiply this by 1 over 2, you also multiply the power of 4, which is 1, by 1 over 2. That is why it's an equation. All right, whatever you do for this side, also do for this side. Do me, I do you. All right. So now what's the essence of multiplying by the multiplicative inverse? So that the power of x will become 1. We are looking for x and not x squared. All right. So we have x raised to the power of 1 over 1, and 1 over 1 is 1. So this is x raised to the power 1 to be equal to 4 raised to the power of half. And if you have seen the video on the laws of indices, you will know that the law to be applied here is fractional index, and you have x to be the square root of 4, and then square root of 4 is 2. Okay, so these are the two forms that indicial equation can take. Either the unknown is in the exponent or the unknown is in the base. Having this knowledge, now we can comfortably look at WAEC questions on exponential or indicial equations. So the first question I have says, question 1. If 9 raised to the power 1 minus x is equal to 27 raised to the power of y, and x minus y is equal to minus 1/2. The question says find x plus y. Find x plus y. Okay, so we have two pairs of linear equations to solve simultaneously. Okay, so you see the second equation, we don't have any issues with that. But then the first equations have the unknowns in the exponents, right? Look at it, you have x here, you have y here. So which form is this indicial equation coming in? Is it in the first or the second? So we see it's in the second, right? When the unknown is in the index. Sorry, the first form. When the unknown is in the exponent. So what do? We express the bases to be the same so that the bases can cancel out and then we pick the powers. All right, so 9 and 27 are all multiples of 3. So we have 3 raised to the power of 2. You open a bracket. I hope you know why we are opening a bracket. Because if you do not open the bracket, if you don't introduce this bracket and just write 2 here, you end up multiplying only 1 with the 2. So 27 is 3 raised to the power of 3. So at this point, they can cancel out. So we're coming to the second equation. So opening up the bracket, you have 2 times 1, 2, minus 2 times x is equal to 3y. So we need to rearrange this equation to be like this. So rearranging so that we can solve simultaneously for x and y, we'll have minus 2x minus 2x minus 3y is equal to minus 2, and then x minus y is equal to minus half. Okay, so to solve this second equation, having that mixed fraction or mixed number, it will be an issue. So what do? We first convert to improper fraction. Okay, so when we convert, if we convert this to improper fraction, we will have x minus y is equal to minus 3 over 2. We still have fraction, but we can actually clear this fraction. So to clear this fraction, multiply through by what? This, the LCM. All right. So you know the denominator of everything here is 1. So the LCM of 1 and 2 is 2. So multiply through by 2 so as to clear fractions. So doing that, you will have 2x minus 2y is equal to minus 3. So let's bring down the first equation. Minus 2x minus 3y is equal to minus 2. So we call this equation 1, and then we call this equation 2. So solving simultaneously using the elimination method, the coefficient of x in equation 1 and 2 are the same, just that the signs are different. All right. So when the coefficients are the same but the signs are different, we add. But when the coefficients are the same and the signs are the same, we subtract. Okay, I believe you have your pen and your paper. So if we add this, this will become 0. And then if we add this, this becomes minus 5y. And that is equal to minus 5. So divide both sides by the coefficient of y. Y becomes equal to 1. So to solve for x, we can substitute y equals 1 into any of the equations. It can be equation 1, it can be equation 2, whichever one you prefer. So minus 2x minus 3 into 1 is equal to minus 2. So opening up the brackets, we will have minus 2x minus 3 is equal to minus 2. So we collect like terms. So collecting like terms, minus 3x will go over to the other side. And going over to the other side, we'll have minus 2 plus 3. All right. So minus 2 plus 3 will give us 1. So divide both sides by the coefficient of x. We will have that x is equal to minus half. Now we've gotten x and we've gotten y. And then the question says find x plus y. X plus y. So x plus y is going to be minus half plus 1. So minus half plus 1, what's the denominator of 1 here? You have it to be 1. So when you take LCM, 2 into 2 gives you 1, times minus 1, you have minus 1. 1 into 2 is 2. 2 times 1 plus 2. So minus 1 plus 2 will give you 1 over 2. And that's our answer. So I believe you understand fully. But if you do not, please drop a comment in the comment section and I will attend to you. Okay, so the next question. 1 over 8 raised to the power 2 minus 3y is equal to 2 raised to the power of y plus 2. We are to find y, right? Good. So what do we do? Now, if you have seen the video on indices, you would know that we're going to be looking at the law of negative index, rather. So to bring this 8 up, because we can't express in the same base here, so we have to take the 8 up. So we have 8 raised to the power of minus 1. That's another way of saying 1 over 8, right? Good. So the original index of 8 is 2 minus 3y. We put it in a bracket so that the negative 1 will affect all of them. And that is equal to 2 raised to the power y plus 2. So the next thing to do is to turn 8. 8 is a multiple of 2, right? Good. So 8 is the same as 2 raised to the power 3. Alright? So we have 2 raised to the power of 3. Okay, there is a minus 1 here. So that minus 1 will multiply this 3. So we have minus 3 into 2 minus 3y is equal to 2 raised to the power y plus 2. Now that we have them to be in the same base, the bases can cancel out. So we pick the powers and we work with them. So we have minus 6 plus 9y is equal to y plus 2. So if we collect like terms here, plus 2 going over to the other side will become minus 2. And plus 9y going over to the other side becomes minus 9y. So we have minus 8 is equal to minus 8y. So dividing both sides by the coefficient of y, we'll have our y to be equal to 1. And the instruction says find y. Okay, so I'm going to give you just 2 questions to try out and then give me your feedback. But before you try them out, I will suggest that you repeat these ones by yourself. So try these 2 questions and give me a feedback in the comment section. Number 1. Solve for x. Solve for x in 0.25 raised to the power of x plus 1 is equal to 16. The second one, find n if 9 raised to the power of n times 1 over 3 raised to the power n minus 1 is equal to 27 raised to the power of n plus 3. Okay, so I want you to try these 2 questions by yourself. Were you able to do it correctly? Do you have any issues, confusions, whatever it is, just drop it in the comment section. All right, in our next video, we're going to be looking at other forms of this exponential equation. Exponential equation can actually land you to quadratic equation. So we'll be looking at that in our next video, and I believe you will be there to join us. All right, thank you for watching. Do have a lovely day. Please invite your friends and subscribe if you're yet.